The mean absolute deviation is a measure of dispersion that indicates the average spread of data points in a distribution from the mean. It is defined as the average of the absolute deviations of data from the mean. In this video, I'm going to show you how to compute the mean deviation from mean for individual, discrete, as well as continuous series data. So here we have three data sets of children attending clinics in Nigeria. Dataset A is the age in years of 5 children attending the nutritional clinic in Samaru Zaria on the 31st of January 2025. This is an individual series data. The second dataset B is the age in years of a sample of 14 children that attended the immunization clinic in Samaru Zaria in the last week of January 2025. Alright, this is a discrete series data set. While the last data set C is the age of data in months of all under 5 children who attended the growth monitoring clinic in Samaru Zaria on January 31st, 2025 with a continuous series. That's data set C. What is the mean absolute deviation for these three data sets and how do we interpret these findings? So let's start with individual series data set. That's data set A. The formula for mean absolute deviation for ungrouped data or individual series data is given by the summation of all the absolute deviations from the first value to the nth value, all divided by n. Sigma here is the summation of values from the first to the last. These double lines are called modulus. It presents the absolute value of whatever is within it. X subscript I is the value of the ith data element, meaning the value of the index data element. X bar is the mean of the data set, and n is the number of data elements. Let's use this formula to find the mean deviation of this data set of the ages of all the children who attended an immunization clinic in Samaru Zaria on the 21st of January 2025. What is the mean absolute deviation or the mean deviation from the mean of this data? To begin with, let's represent each of our data points with the proper statistical notation. So this first data point is our x1, the second is x2, then 6 here is x3, 5 is x4, and our x5 is 9. Awesome. We can see from this data that there were only 5 children because there are 5 ages or 5 data points, right? So our number of data values n is equal to 5. Next, we need to find the mean of this data or x bar. To find the mean, we will add all the data values, that is from x1 to x5. We'll add all these values together and divide the sum by the number of data values, n. So x bar will be equal to x1 plus x2 plus x3 plus x4 plus x5 all divided by n. So we'll have x bar is equal to 1 plus 4 plus 6 plus 5 plus 9 all divided by 5, and that is 25 divided by 5. That's a mean of 5 years. Alright, so now we have x1 to x5, we have n as 5, and our mean x bar as 5 years. Now we just need to find the absolute distance between each value from the mean, i.e. we need to find the absolute deviations. And that's the modulus x subscript I minus x bar part of the formula. For the first value x1, the absolute deviation of x1 from the mean will be x1 minus x bar, and that will be 1 minus 5. That's minus 4. And when we apply the modulus, the absolute value will be 4. Awesome. Then for x2, it will be 4 minus 5. That's minus 1. And so the absolute value is 1. Then for x3, we will have 6 minus 5. And that will give 1. And the absolute value will be 1. And for x4, we'll have 5 minus 5. And that will be 0 with an absolute value equal to 0. And lastly, for x5, we will have 9 minus 5 with an absolute value of 4. Now we have all the absolute deviations. All that is left is to find the mean of these absolute deviations. Remember, the definition of mean absolute deviation is the average of the absolute deviations from the mean. And according to the formula, we will need to sum all the absolute deviations together and divide by n, which is 5. So 4 plus 1 plus 1 plus 0 plus 4, that's 10. And finally, we divide by n, which is 5. So we have 10 over 5, which will give us a mean absolute deviation of 2. So what does a mean absolute deviation of 2 imply? It implies that on average, all the ages of the children attended to on that day were 2 years from the mean age of the data. Easy peasy. So this is how to compute the mean absolute deviation for ungrouped data with individual series. Now let's go on to the discrete series data. That's data set B. The formula for mean absolute deviation for discrete series data is given by the summation of the product of the frequencies and the absolute deviations from the first value to the nth value, all divided by the number of data values. Sigma here is the summation of the values from the first to the last. F sub I is the frequency of the occurrence of each data value, i.e. the frequencies of x subscript I. These double lines are called modulus. They represent the absolute value of whatever is within them. X subscript I is the value of the ith data element, meaning the value of the index data element. X bar is the mean of the discrete series, which has its separate formula, and n is the number of data values. Now let's use this formula to find the mean deviation of this data set of the ages of all the 14 children who attended a nutritional clinic in Sama Rosaria on the 27th of January 2025. What is the mean absolute deviation, or the mean deviation from the mean, of this data? We can see that this data is a simple frequency distribution of the ages of children, right? And this is represented using a discrete series. A discrete series is a data set that's represented in a table with only two columns or rows, with the first representing the values of the variable and the second indicating the frequencies of each data value. To begin with, let us reorient the table to make it easier to compute the mean deviation. So we'll have age here and then the frequency. And then we had 5 children who were 1 year old. Then there were only 2 children who were 4 years old, 4 6-year-olds, and 3 9-year-olds. So the total number of children will be 5 plus 2 plus 4 plus 3, and that will be 14. Awesome. Now to apply this formula, let's represent the data we have with the proper statistical notation. In statistics, the actual data values of the variable are usually labeled as x. So our variable here is age, right? So let's call it x subscript I. This implies that for each data value for age, they will be tagged with the index of x. So this first data point is our x1, the second is x2, then 6 is x3, and 9 is x4. Great. Now let's label our frequency column as f subscript I. That's the frequency, right? And when we add all the frequencies together, we will get the total number of children. So our number of data values n is equal to 14. Now remember, even our question says it represents the ages of 14 children. So our n is 14. So what is left for us to find is the mean of this data, or the x bar, since we already have all the other elements. To find the mean for a discrete data series, it is given by the sum of the product of each of the frequencies and the corresponding data values divided by the number of data values, which is n. So let's add 2 extra columns for this. Now what we need to do for each data value is to multiply it by its corresponding frequency to get the f of x. And then when we sum all these together, we get the sum of the product of each of the frequencies and the corresponding data values. That's the summation f of x. So for the first value x1, we will multiply 1 by 5 and thus we'll have 5. For x2, we'll multiply 4 by 2, giving us 8. For x3, 6 by 4, and that will be 24. And for x4, 9 by 3, which is equal to 27. And our total of 5 plus 8 plus 24 plus 27 is 64. So the total is 64. Summation f of x is 64. Awesome. So we already have the numerator for this formula as 64. And then we divide by the total number of values, that is n. And our n is 14. So 64 divided by 14 would have a mean of 4.6. So our x bar is 4.6 years. Alright. So now that we have all the elements of the formula, let us use the table to our advantage while applying the formula. So looking at the formula, we will need to find the absolute distance between each value from the mean, i.e. we need to find the absolute deviations from the mean. That's the modulus x subscript I minus x bar part of the formula. So let's add it to the next column. For the first value x1, the absolute deviation of x1 from the mean will be x1 minus x bar, which will be 1 minus 4.6, since our mean is 4.6, right? And that's minus 3.6. And then when we apply the modulus, the absolute value is 3.6. So we'll take out the negative sign, and absolute values are always positive. Alright, then for x2, it will be 4 minus 4.6, that's minus 0.6, and the absolute value is 0.6. Then for x3, we'll have 6 minus 4.6, and that will be 1.4, and the absolute value is 1.4. And for x4, we will have 9 minus 4.6, and that will be 4.4 with an absolute value of 4.4. And here we don't have any use for the sum of absolute deviations, so we'll leave it blank. Now we have all the absolute deviations. The next thing according to the formula will be to multiply each of the frequencies with absolute deviations. So let's add another column. Here this column will be f subscript I multiplied by the absolute deviations which you just calculated. So for the first value we have the frequency of 5 and an absolute deviation of 3.6. So 5 times 3.6, that's equal to 18. Then for the second, 2 times 0.6, that's 1.6. Then 4 times 1.4, that's 5.6. And lastly, 3 times 4.4, that's 13.2. Awesome. And if we add all this together, we would have 18 plus 1.2 plus 5.6 plus 13.2, giving us 38. And if you notice, this is already the numerator of our formula. This is the numerator of our mean absolute deviation formula. And that's the sum of the product of each frequency and the absolute deviations of each value from the mean. And according to the formula, we need to divide this by the number of data values, or n. So we'll have 38 divided by 14, which will give a mean absolute deviation of 2.7. So what does a mean absolute deviation of 2.7 imply? It implies that on average, all the children that were attended to in the immunization clinic on that day were 2.7 years about the mean age. Easy peasy. So this is how to easily compute the mean absolute deviation for discrete series data. And finally, let's find the mean absolute deviation for the third data set. That's the one with the continuous series. That's dataset C. The formula for mean absolute deviation for group data of the continuous series type is given by the summation of the product of all the frequencies and the absolute deviation from the first value to the nth value, all divided by the number of data values. Sigma here is the summation of the values from the first to the last. F sub I is the frequency of occurrence of each of the classes or groups. The double lines are called modulus. They present the absolute value of whatever is within it. X sub I is the mid value or midpoint of the class interval. X bar is the mean of the continuous series data, which has its own formula, and n is the total number of data values. Now let's use this formula to find the mean deviation of this data set of the ages in months of all the 14 children who attended a nutritional clinic in Samaru, Zaria in the first week of January 2025. What is the mean absolute deviation, or the mean deviation from the mean of this data? Now we can see that this data is a group frequency distribution of the ages, and this data is organized using a continuous series distribution. To begin with, let us reorient the table to make it easier to compute the mean deviation. So we have the age here and then the frequency. And then we had 3 children who were aged between 0 to 9.9 months. Now remember, this is an exclusive class interval. So the upper limit of 10 months is excluded from this group. Now if you want to get a better understanding of the different types of class intervals, inclusive versus exclusive, then check out the link above or in the description of this video. So let's continue. Then there were only 2 children who were between 10 and 19.9 months old, 5 children between 20 and 29.9 months old, and 4 between 30 and 39.9 months old. So the total number of children is 3 plus 2 plus 5 plus 4, and that will be 14. Awesome. Now to apply this formula, let's first represent the data we have in this table with the proper statistical notation. Let's start with the first element in the formula. That's the frequency. So we label this as F sub I. Our total number of children, which is the sum of all the frequencies, is 14. So our n is 14. In statistics, the actual data values of the variable are usually labeled as x, and our variable here is age. However, unlike individual series data and discrete series data, we don't have information about the actual age of these children. We only have their grouped age. But we will need one value to represent the age of each class. According to the formula, we will use the midpoint of the class interval. So let's create a new column to enter x sub I for each class. To calculate the midpoint, we will add the lower limit plus the upper limit and then divide by 2. So for this first class of 0 to 10 months, our lower limit is 0 and our upper limit is 10. So for the midpoint of this class, we will add 0 plus 10 and then divide by 2, and that will give us 5. So our x sub I for the first class is 5. Awesome. For the second class, 10 plus 20, that's 30 divided by 2, and that will give us 15. So our value here is 15. For the third class, 20 plus 30 divided by 2, that's 25. And for the last class, 30 plus 40, that's 70 divided by 2, and that's 35. So we have our f sub I, our n, and now our x sub I. What is left to complete this formula is the x bar, which is the mean of the data. Now, to find the mean for a continuous series data, it is given by the sum of the product of each of the frequencies and the corresponding class midpoints, all divided by the number of data values, which is n. So let's add another column for multiplying the frequencies and the corresponding class midpoints. We will call this f of x. That's the frequency multiplied by the x. Now, what we need to do for each data value is to multiply it by its corresponding frequency to get the f of x. So for the first class, we will multiply the frequency of 3 and the midpoint, which is 5, and thus we would have 15. For the second class, we'll multiply the frequency of 2 and the midpoint, which is 15, and we would have 30. For the third class, we'll multiply the frequency of 5 and the midpoint of 25, thus we would have 125. And for the last class, we'll multiply the frequency of 4 and the midpoint of 35, thus we would have 140. And our total will be 15 plus 30 plus 125 plus 140, so we'll have a total of 310. So the summation of f of x is 310. So we already have the numerator of this formula as 310, and then we'll divide by the number of data values, that is n, and we know n is equal to 14. Right? So 310 divided by 14, that's 22.14. So our mean, that's the x bar, is 22.14 months. Alright, so now that we have all the elements of the formula, let's break the numerator of the formula down to make it easier to compute. Let's first find the absolute distance between each class midpoints from the mean. That's the modulus x sub I minus x bar part of this formula. So let's add it to the next column. For the first class, the absolute deviation of its midpoint from the mean will be 5 minus 22.14, that's minus 17.14. And when we apply the modulus, the absolute value is 17.14. Awesome. For the second class, it will be 15 minus 22.14, that's minus 7.14, and so the absolute value is 7.14. Then, for the third class, we will have 25 minus 22.14, and that will be 2.86, and the absolute value is 2.86. And for the last class, we will have 35 minus 22.14, and that will be 12.86 with an absolute value of 12.86. And we don't have any use for the sum of absolute deviation, so we'll leave here blank. Now that we have all the absolute deviations from the mean, the next thing according to the formula will be to multiply each of the frequencies with the absolute deviations. So let's add another column. Here we will label it f sub I multiplied by the absolute deviations. So for the first class, we have a frequency of 3 and an absolute deviation of 17.14. So 3 times 17.14, that's equal to 51.4. Then for the second, 2 times 7.14, that's 14.3. Then 5 times 2.86, that's 14.3 again. And lastly, 4 times 12.86, and that's 51.4. Awesome. And if we add all these together, we will have 51.4 plus 14.3 plus 14.3 plus 51.4, giving us 131.4. And if you noticed, at this point, we already have the numerator of our formula. That's the sum of the product of each frequency and the absolute deviations of each value from the mean. Great. So the last thing we need to do now, according to the formula, is to divide this by the number of data values, or n. So we'll have 131.4 divided by 14, which will give a mean absolute deviation of 9.4 months. Awesome. So what does a mean of 22.14 months and a mean absolute deviation of 9.4 months tell us about our data on the ages of children in the nutritional clinic? Well, a mean of 22 months indicates that on average, the values in our dataset tend to be around 22 months. And the mean absolute deviation of 9 months suggests that the typical difference between each child's age and the mean is 9 months. In other words, while the average age of children that were attended to in the clinic was 22 months, the individual ages of the children deviate from the mean by 9 months on average. Easy peasy. So this is how to compute the mean absolute deviation for continuous series data. Awesome. Now we have a mean of 5 and a mean absolute deviation of 2 for dataset A. And for dataset B, we have a mean of 4.6 and a mean absolute deviation of 2.7 and a mean of 22.14 and a mean absolute deviation of 9.4 for the third dataset C. Now, how do we interpret these findings all together? Well, for the first dataset, the mean deviation is 2 units away from the mean, indicating that, on average, all the data points in this dataset are relatively closer to the mean. When compared with the second dataset, despite having a slightly lower mean of 4.7 than the data in A, the mean deviation is slightly higher than that of A, indicating that the data points in B are more spread out around the mean than in A. This suggests that the variability or dispersion in B is higher than that of A. In the third dataset, with a mean of 22 and mean absolute deviation of 9, this dataset has a higher variability around the mean, indicating that, on average, all the data points in C are 9 units away from the mean, thus reflecting a wider spread of values when compared to the other 2 datasets. So in other words, the higher the mean absolute deviation, the higher the dispersion in a dataset. So dataset C is more dispersed than B, and B has more variation or dispersion or variability than A. So this is how to compute and interpret the mean absolute deviation of individual, discrete, as well as continuous series data. Now it's your turn to answer a quick question. We have 2 data sets, A and B. A has a mean absolute deviation of 5 and B has a mean absolute deviation of 12. Which one has more variability around its mean? Please put your answers in the comment section below and do not ignore. And if you have gained value with this video and you want to see more cool statistical explanations like this in future, then don't forget to give us a like and subscribe. And whilst you're there, remember to hit the notification bell button so you get notified of our future videos. And if you want to learn a bit about standard deviations, check out this video here. And for coefficient of variation, then check out this other video right here. And as always, thanks for watching.